Okay, you've created a resource and you have some metadata that was generated at the time of creation of the resource and updated over the lifespan of that resource. But now you want to generate more metadata and you want to generate it automatically. One example of data or metadata, and this is another place where that distinction gets very blurry, is the Flesch-Kincaid readability tests, which are statistics that give a score for how difficult a text is to read. And I'm just using this as a fairly simple example. And actually there are two Flesch-Kincaid tests. There's reading ease and grade level. And in fact, the Flesch-Kincaid tests aren't even the only readability statistics out there, and there's some debate around the relative merits of one readability test versus another, but the Flesch-Kincaid test is probably the best known, so we'll use it as an example. So the Flesch-Kincaid reading ease statistic gives a score from 1 to 100, where 0 is the hardest text to understand and 100 is the easiest. And then the grade level statistic gives a grade level in the United States educational system at which you'd be expected to be able to read and understand a text. And both of these statistics are fairly simple calculations using data that you can extract from a text. Things like total number of words and total number of sentences. Now, I hear all you linguists out there saying, well, it's not that easy to define what a word is. It's not that easy to define what a sentence is. Yes, that's certainly true. Is a hyphenated word one word or is it two? Is a name like Chapel Hill one word or is it two? And it's not so easy to define what the boundaries of a sentence are. But here's the thing. We don't care. The Flesch-Kincaid measures have a definition that they work from of what a word is and what a sentence is. And you can argue with those definitions, but that's where these statistics start from in their computations. So, once you have definitions of word and sentence and whatnot, you can do some fairly simple math, and hey presto, a readability score, which is metadata about an original text. Now, so this isn't quite so abstract. Let's actually look at a Flesch-Kincaid score for a text. I've copy and pasted the text of this semantic web article by Tim Berners-Lee, James Hendler, and Orolosula from Scientific American, which I linked to as a resource for a previous video, into this site, which computes Flesch-Kincaid statistics. Now, let's scroll up a little bit, and what we get is a reading ease score of 47.7. And remember, I said it was out of 100. So this is, about halfway there. It's a relatively easy text to understand. And then we get the grade level one would be expected in the US education system to be able to read and understand this text at grade 12. And then you get a bunch of other readability statistics as well. Now, I've actually kind of cheated a bit here because Microsoft Word also has a function that computes the Flesch-Kincaid score of a document. And I've copy and pasted that same text, the text of the semantic web article, into a Word document and computed the score here. Now, Microsoft Word doesn't do this by default, but you can edit a setting in Word so that when you do a spelling and grammar check of a document, you also get these readability scores. And it's interesting that the reading ease score is different here in Word than it was on that website. But again, this isn't really the point. The point here is not to show you tools that create Flesch-Kincaid readability scores. The point is to show you that it's actually not that difficult to automatically create metadata after the creation date of a resource, as long as that data is something that can be easily computed, like the Flesch-Kincaid statistics, which are just fairly simple calculations. Similarly, you could imagine some descriptive statistics being generated about data sets containing any kind of values, numerical values, for example. The United States Census, for example. How many households worth of data is in the census data set? What's the mean and median and range of household incomes in the United States? What's the percentage breakdown of race and ethnicity in the United States? Those would be fairly easy calculations to make, even though the census data set is very large. They would be easy calculations to make because it's a numeric data set by and large. And those could be considered metadata about the census data set. But you don't have to stop with simple descriptive statistics. Anything that can be computed about a resource can be generated automatically as metadata. And there are lots of ways to analyze a text. Readability is only one. And there's a whole field of text analysis out there. One very common approach to analyzing texts is what is called text categorization. And I guarantee you that you have seen this in action, even if you didn't realize it at the time. So let me ask you a question. Does whatever email client you use have a spam folder? I bet you it does. You can create rules, you can create filters that will dump emails in the spam folder, right? You don't like such and such a coworker, create a filter. If an email is from such and such an individual, throw it in the spam folder, right? Never have to see an email from that person again. I do not actually recommend that you do that for any of your actual colleagues. But most email clients have built-in rules for filtering out spam. And it doesn't really matter what those rules are. The point is there is a set of rules that exist to automatically categorize the texts that are your emails. Is this email spam or is it not? It's a simple binary categorization, spam or not. But you can do a lot more to automatically categorize and automatically analyze texts. One of the more popular forms of text analysis these days is something called sentiment analysis. Now, sentiment analysis gets used a lot in political campaigns and by marketing departments in companies, etc., to see what people think about your brand. What are people saying about you on, for example, Twitter? Now, Topsy is a company that does this kind of analysis on social media, and they have a free tool on their site, which is kind of a teaser for their fuller paid products. And let's use that just to see some sentiment analysis in action. So if we search, let's say, just Twitter for metadata, what we see, in addition to a list of tweets that contain the word metadata, we see the sentiment score, which is 54, which means 54% of the tweets have a positive sentiment about metadata, and the rest have a negative sentiment about metadata. So, more than half of Twitter feels good about metadata, which is wonderful. I hope you are among them. Now, if we search for, let's say, Congress, now forgive me for using a United States-centric example, we have a sentiment score of 34. Only 34% of the tweets in the last hour are positive about Congress. So more people on Twitter feel good about metadata than feel good about the United States Congress. I suppose that's a pretty reasonable measure of success for me here. At any rate, sentiment analysis is interesting stuff. It involves figuring out what words and what words used in what contexts carry what emotional weight when used in a written text, positive or negative. But how sentiment analysis works is not really important here. The point is, you can automatically generate metadata about a text, in particular the sentiment of a text, which can go well beyond the actual content of the text itself. So, the point of showing you all of these examples is not to show you readability statistics or sentiment analysis, but to show you that fully automated metadata generation is totally feasible. So, the application and the operating system you're using generate data about files. And that data can be tacked onto a file or associated with a file as metadata. Or you can feed your file to some kind of an algorithm, a readability statistic computation, for example, which then spits out some additional data about your file, which can also be metadata about that file. So, all of this metadata generated automatically is pretty simple stuff, though. Like I said, data extracted from the file system, simple counts, word counts, sentence counts, etc., easily computed statistics. But what if you want more than that? What if you want richer metadata than just simple descriptive statistics?